JSON is a good thing or not, since no one is coming, but I assume everyone else has corona. Welcome. So today, like last week, I assume that you've watched the video. If you didn't, doesn't really matter, so I'm going to do an overview, like show you software around what you see in the video, a bit of history, a bit of blah, blah, blah on my side, and I'm going to introduce the assignment number 2. I'm aware that the deadline is Friday for the first one, Thursday, I don't know. So I can go quickly over the code, you decide, but then maybe it's better if next Monday I will be here as well, so I can go more over the code. But the code is very little, so but it's up to you. You let me know after. But okay, the lesson now is about 3D city models, or semantic 3D city model. In the video, I explain what is the difference between a 3D city model and a semantic one. That's very important. But the first thing I want to know is, did you learn what is JSON and XML, JML? Where did you learn that? Okay, it's not formally in any course, that's what I mean. Okay, I'll go quickly then, because I think it's important. There's a few things that you should know, especially JSON. This is what you're going to be using right now. So JSON means the JavaScript object notation. A lot of people think that JSON is linked to Java or JavaScript is linked to Java. It's not. So Java and JavaScript are two different things. JavaScript is the language of the web, more or less. And JSON is something that started with JavaScript object notation, so to exchange information on the web. But now it's got nothing to do with the web anymore per se. Every language is supporting JSON, and JSON is probably the most popular data exchange format. So 20 years ago, Google, all the big ones, they all had their API. So if you want to query and get data in XML, but they all switched to JSON because JSON is just simpler, lighter, and more fun and simpler to work with. In geo1004.2022 or maybe other courses, we give you config files in JSON, like that one. So it's text-based, easy for you to understand, but what's more important is that every computer has native, or every language has native support for JSON. And if you look at the file here, you just see some keys, some properties, it looks very abstract, but what you should notice is that this is basically two data structures. So a JSON object, you have either a dictionary, a Python dictionary, or a hash map, or a STD map in C++, depending on what you call it. That's a pair of a key or a name and then a value. And you also have an array. And then you can put different things into these arrays or into these structures. You can have numbers, floats, integers, string, boolean, null, or something else. And a file like that one is basically just a mix and match of these two. So curly bracket means a dictionary. So the first thing is a dictionary that has several keys. And then if you go here, the square bracket, I think it's called in English, then it's an array. So basically here you have several keys that you can access. So if you say give me the first name, you get John. If you say give me the phone numbers, then you don't get a string, you get an array. And then you can iterate over your array, and then your array is an array of what we call a JSON object. But the JSON object is basically a dictionary that has a type, and here a number, and so on. And if you had children here, you could also just store an array of something there, but you can also have an empty array. So it means that I have an array of nothing. But what's important is that if you want to read that with Python or C++ or Rust or whatever you're using, any language can just take this and then transform automatically all this to an array of a dictionary of array, and so on. If you compare this to XML, I won't explain much what is XML because I hate XML. and we don't use it in this course. You will, if you want to really know and work with XML, I think you will do it in geo1007, the web, how is it called? Web programming course. GeoWeb Technologies, exactly. And if you take the elective that's called Energy Modeling with Giorgio next semester, he's a big fan of XML. I'm a big fan of JSON. We don't really agree, so you can take the course, but you're going to work a lot with XML and JML if you go there. But XML used to be the language of the web. Now it's more JSON. So XML is basically the extensible markup language. Maybe you've seen some of them. So all the languages that we use on the web, many of them are implementation of XML. So HTML, GML, the geography markup language, KML, which is the K-hole markup language that is used on Google Earth. A lot of formats like the doc format or the Word format, if you add an X, it's because it's an implementation of XML, RSS, SVJ, blah, 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 blah. There's many. So it's still used a lot, but it's a bit more complex, and most APIs are mostly using JSON these days. XML looks like that. So basically, it's not, you cannot take the whole, it's a tree that you create, but you cannot convert it directly to data structure as you do with JSON, where you have arrays and dictionary. So you basically have this. I have a node, then you have a different fields or different tags that you have. And if you want to process the information with a language, then you need to write yourself the logic, how that works and everything. So you need to basically say all of these should be in an array. So that's your job to decide that, while in JSON, it's kind of done for you. It's called extensible because this is the idea that you have the start of a tag and then the end of a tag, and you can put whatever you want. So GML is basically geography markup language where, well, you can, I don't have an example here, but you have a X, Y, Z or a line or something, so you can store all these things. Yeah, that's a nice thing about JSON. That's it, there is to know. So now if you start to work with JSON, 2 data structure, arrays and dictionaries. The rest, yeah, the rest is done. So if you, who watched the video, can be honest or not? Okay. In the video, I explained what CityGML is. So long story short, CityGML started in 2005. It's an international standard from the OGC, the Open Geospatial Consortium, for representing and storing 3D city models. In the video, I say it's the least bad of all the data models that exist, because I don't really like it, but there's nothing better. So that's what we use in my group to represent cities, to exchange cities. It frustrates me. I find it difficult to work with, but then there's nothing better. All the other options are worse. So this is what we use. It exists since 2006, I think. We're currently at version 3.0. So the version 3.0 was released last summer. And it started as a CityGML. It started as an encoding in XML of 3D city models. But it has evolved into being a data model. So they didn't want to change the name because they think that their name has a PR value, let's say. I don't think so, but they call it CityGML, but there's no GML in it. So CityGML is basically a data model to represent a city, and CityGML is a set of UML models. So you learn what UML models are. So right now, if you read what is CityGML, it's a very simple UMLs that you can read easily. 400 pages of this. And then, sorry? I don't know. The old one used to be 300 pages or something like this. But basically now the word CityGML means a data model and a GML encoding. It means both. And as I said, So, okay, long story short, I've been using CityGML since 2008 when I moved to the Netherlands to do my work, and I always had problems to deal with it because the files are complex, hierarchical. I'm a developer, so I was always getting angry. But then I was also teaching a course that's called, well, this course that had other variation where I had 3D city models. So I was explaining to students how nice it is to build your own city, analyze it, and then they thought, nice. And then we went to the lab, and this is a real slide I used recently, and then this is really what students were telling me, like, why is it so complex? And in 2015, 16, I started to feel a bit kind of ashamed. So I use that, but I'm aware that it's difficult, and I said we can do better. So I decided summer 2017 with some of my colleagues to say we take the CityGML model and then we convert it to JSON so that we obtain CityJSON. So I started here in 2017, then my colleagues helped me. And then we released slowly versions, and the first time we released version 0.1, it was a bit rough around the edge, but I put it online, and a lot of big people in the world became angry. Why did you do that, everything? So that I knew that there was something good. So if you do something that pisses off people, it's probably because you're doing something good. So I continued every year with students, so in this course and in other courses, to ask students to work with CityJSON and give me feedback how it goes with the software, with the specs. And after 3 years, I think we achieved something pretty good. And now CityJSON has a website, cityjson.org, but more importantly, it's an international standard, so it's been accepted by the OGC last summer. So this is something I'm pretty proud of, me as a geomatic staff, because this is something we've done. A lot of the world is using it, so a lot of cities, Amsterdam, the whole of the Netherlands is offered now in CityJSON and not in CityGML. So people are moving away slowly from CityGML and are going to CityJSON, and it's something that was developed here by us, the staff, but also with students in labs and with homeworks and with everything. So the website is giving all the details, the software, there's tutorials, there's many things. So for the homework, you'll need to go over it. If you find something not clear, let us know, we can update it. This is maintained by us, basically. Yeah, why did we do that? I just gave you the funny story around it, that why we developed it, but there's also real reason, and if you see, it's me and Ken, the first two authors, and the other ones are PhD students or ex-PhD students in the group. We developed this and we published it, so all the reasons are there, but the main reasons are summarized in the 3D book, basically. So yeah, CityGML, a data model, GML encoding, and then CityJSON is basically another encoding. It does the same thing as CityGML, just that it's in JSON. We're currently at version 1.1. We released it, not sure when, last summer, I think? No, not last summer, last few months ago. It's an OGC standard, so it means that people in different government can use it. So I can use it. Anyone can use it, but let's say a lot of countries have law that says that if you want to release your data in a certain format, this format needs to be an international standard. So now, since CityJSON is an international standard, then a lot of the government, at least in the Netherlands and in many countries, can use it. Yeah, so how a file looks like, it looks like this. If I just go quickly, that's JSON, as I said, so a mix of dictionary, map, and arrays. So basically, the file says what is the type. I'm CityJSON, version 1.0. You can also have metadata. There's more possible, the CRS. So for example, this one says that the current reference system is EPSG 7415. 7415 is the 3D version of 28992, the Dutch RD new. Then you have a list of objects. And what's important is that all the objects are indexed by their IDs. So basically, if you have many buildings, you can give them a unique ID, the name or whatever. And then all of them are indexed by their IDs. And then a building has different attributes and can have one or more geometries. And the geometries, what is special is that it uses the same system as OBJ. So you don't list XYZ, XYZ. You have the IDs of the vertices. So it uses exactly the same thing as OBJ. We copied that behavior. So at somewhere you have a list of vertices. And there's many more things possible, like you can have materials and textures, for example, because often people want to put materials and textures to their buildings. That's important because you will notice it in the homework as well. If you have a building, you can also have building parts. So basically here what I say is that I have several city objects. I have 3. The first one is called ID1, ID-1. It's a building. It's got a roof type. It's gable roof type. And it's got children. So it means that I'm a building and I also have building parts, which can be extension of a house or something like that. And I say I have 3 children, ID 56, ID 832, and my balcony. And then all the other ones are listed somewhere also in that list. So ID 56 is a building part that has as parents this one, so we link them. And this building part could have a geometry, attributes, and so on. The specification will give you all the gory details. So if you're not sure how to store something, how to do something, you need to go check in the specification. It's not 800 pages. We made it on purpose, very short with snippets of code so that you can see how to use something. And you will need to go see that because we will give you for the assignment the file of Delft and you will need to modify it. Yeah. We use the same system as Collada, or Collada. You know Collada? C-O-L-L-A-D-A. Basically, you just store externally a PNG or a JPEG of a file, and then for every texture, then you basically do a mapping between the location of the vertex and it's called a UV coordinate. So even if you Google UV coordinates, maybe you've done that since you work in architecture. Since you have a texture, then you can say UV, it's the U and V or the 2 axis, and then you just say I start from pixel 200, 310 to that, and then take that one and then warp it to something else. So CityJSON is easy to work with, I think, but we've developed a lot of software with it. Most of the software right now is developed by us, me, Ken, my colleagues, but also former students of geomatics who did some special courses. So there's a course called, seems you didn't all know, but research orientation. What is the course? Then, so we have a course called Research Orientation. Sibran is doing it with me. I told him about it. So if you want to have 2 credits, you can define your own topic with a supervisor, and then you define a topic with a supervisor. If it's approved, then you just do your topic whenever you want in the summer, on the side, whatever. And the result of your research orientation is 60 hours of work where you can have either a, literature review, you want to investigate something, you want to write something, or you can also develop code, and then you get 2 credits automatically. So instead of maybe doing another, if you only have 2 ECTS that you need to get somewhere, or 1, something, that's an easier solution, interesting. So every year we have maybe I don't know, 3, 4 students, 5 students who did it, and some of them, they help us develop software for CityJSON in the last few years. So they kickstarted projects that we finished. I think that, at least for me, that was super useful, and also for them, they contributed to something that people are now using. The first one is the web viewer that's called Ninja. So this was started by 2 students, so 1 student, so we said, can we show our 3D models on the web? So he started to work on it, another student took over, then we took over the project. We called it Ninja. It's developed by Stelios Vitalis, I think, who gave you the Git course. That's what he did during his PhD partly. So now we have a full viewer on the web, so if you go to CityJSON, and we have the web viewer here, and then you can take I think I showed you last week, any file. You can see the file, but you can also click on something and access the data and the attributes that come with it. Oops, sorry. And the attributes that are stored with it. So everything can be visualized and even edited online. So if you would like to change something, you can also do it there. So this was done by students. Another software that you might use is the validator. So if you go to the main page, there's also a validator. So a validator basically says, if you have a file, does it respect the syntax that it's supposed to? So you're supposed, for example, to here. So here I have 2 buildings. So as I said, it should be called type CityJSON. You should have like city objects. But what if, for example, you made a typo somewhere and then you wrote that here? Then you would like to know, because the software that will read your file, they will look for city objects, and computers are not super intelligent, so they might not say, oh, city object is not there, so I'm going to try to permute all the letters to find if you've put something there. No. So if you have a file, you want to make sure that you have type, version, city objects. If you have attributes, that everything is there where it should be and everything. So I've developed a validator that's called CJVal, CityJSON validation, and basically checks for things like that. So type building, if you made an error like this, it would highlight it to you if you made an error like that. Or things like the last one, so the vertices should be integers. But if you put a float, then it will warn it that there's an error. This is also something that was done by a student that helped me to put it on the web, so the validator. So we had a validator until last year that was super slow, and I wanted to have a better validator, which I did, and the student helped me to make such a web page. So basically now if you just go to validator.cityjson, you can just take a file, drag it, take a file, drag it, and then it says the file is invalid because city object is a required property. And if you see, I had changed it, so it means that something is wrong. So the errors are not always like super good. It's not a real compiler, but it should still give you, if it says it's valid, it's valid. If it says it's not valid, something is wrong, but then you might need to do a bit of work to find where the error is. By the way, one way to see nicely a JSON file is to use Firefox, the browser. So in Firefox, if you just drag any JSON file to the welcome page, then you get the whole tree. That's the nicest way to, I think, to browse a JSON file. So basically, this is the JSON file, which is all the properties at the root. So you have city objects, all of them, and then you can explore, and you can also filter, let's say, all the buildings, and they show you everything. There's a lot of ways to look into a JSON file, but I think this is a good one. Another one would be to use something that's called, how's it called? JLess. So if you use JLess, then it creates the same thing in your command line. Parsing a Python file, a CT-JSON file in Python is super simple. As you've done to import the configuration file in DTM course, you can do the same. And in C++, it's the same. I'm going to show you the code after. We also have a QGIS plugin. So if you want to visualize your data, but also have them and then explore them, we have a QGIS plugin that was also developed by Stelios Vitalis. So you need to go into the plugin, install the CT-JSON plugin, and then you can load files, and you can also visualize the attributes of semantic surfaces, and I write that. It's essential for assignment 2. I will explain in a second, remember that, but you will create files, you will improve the files that we have in the assignment 2, but the only way to visually see if you have something good is to use QGIS at this moment, because Ninja doesn't support that at the moment, so you will need to install the plugin to verify one thing if you want manually, visually, sorry. And the last software is CJIO, CT-JSON Input Output. So basically, that's a command line program that allows you to do a lot of things on a 3D CT model. So you can, for example, merge file, clean a file, save a file, crop a file, do a lot of things. And the nice thing is that you can chain the operators. So basically here you will do exactly this to start the assignment 2, which I will explain in a second. So you have CJIO, your file. You can say, I'm going to assign a CRS. So let's say your file doesn't have any CRS or EPSG. So you can say, I know that my file is in the Netherlands, so then I assign it EPSG 7415. Then you pass that to the next operator, the subset. Then the subset will extract all the buildings, and then that one will be passed to the other one. So you don't need to do do something, save a temporary file, open it, do it again. So you can chain everything, and then at the end you say save it to out.json, and then you get a new file that has everything. This is software that was developed again here. Everything has been developed here, but more people are helping us now. So CT-JSON, it's all about us, which might sound annoying for you, but it's super useful for us right now because everyone helped us in the last few years to. So now you have it easy. I think CGIO is working. 3 years ago, students, that was a bit rough around the edges, but it still helped us to build something, identify bugs and everything. And now, since it's in a good state, it's still a small project. Other people are starting to use it because it's usable without us being there looking over your shoulder. If you want to install CGIO, you just need to do pip install CGIO, and then you have it. It's not in Conda. I know some of you use Conda. I cannot be bothered to learn how to package something to put it in Conda. But if I say it every year, if some of you like Conda, you use Conda, you can read how do I make a package Conda. I'm happy to allow you to put the CGIO on Conda. End of parenthesis. It's going to rain this weekend maybe, so something nice to do. Huh? Oh my God, I don't think it should take you more than a day. I don't know though. Maybe, I don't know. It's pure Python, so that should be easy. But I spent a lot of time trying to automate the whole thing to package it and send it to their server. And when it's working, I said, that's it. And someone asked me last year, Conda, and I was like, yeah. But I think it's nice to learn. Yeah, okay, last software, I think this one, not really relevant for you, but a lot of models of the worlds are available in CTGML, and we also have full conversion between CTGML and CTJSON and vice versa. This one is not done by us. It's done by a company in Berlin that uses that and needs that, so they developed it themselves. By the way, if you want to see which cities we have in the world, if you go to the website of my group and you go to Download Open Data, we have something called 3D city models. And then I think I showed you last time. Yeah. So if you take any of these, most of them are in CityGML, so you can just convert them automatically to CityJSON. And one nice thing that wasn't our aim, but that's a nice advantage, is that if you convert a CityGML file to a CityJSON file, you compress the file by a factor 6 on average. So from 4 to 10, maybe 12 sometimes. So these are known files that are publicly available, and you have the size of everything and the compression size. And so for us, we want CityJSON to be used on the web. And a factor, let's say this one, that is the file of Zurich in Switzerland. The original CityGML file is 3 gigabytes, which is not small. And when we convert it automatically lossless to CityJSON, then it's 292 megabytes. And I wrote compression factor of 7. It's not that I'm bad at mathematics. I'm aware that 3,000 divided by 300 should be 10 point something. But the original file of CityGML has a lot of carriage return. So here, if you see, if you want to store something, you have a note, carriage return, space, space, carriage return, space, space. So all these space and carriage returns at the end take a lot of space in a file. So the original file of, I knew that they were taking space, but I didn't really know until I calculated it. So the file of Zurich, 3 gigabytes, I took the whole XML thing, I removed all the spacers, all the tabs, all the returns, and I saved 1 gigabyte in space, which made me laugh, but also cry a bit, because a lot of files are like that. Computer doesn't care if everything is aligned nicely and if you can read it. Computer will just read everything in one shot. So if you remove all the space and characters, then you get to 7 times 292. Oh yeah, last thing, and then the assignment. To get started, what you should do on the website, we have 2 tutorials on the right. We have tutorial getting started with CityJSON and validation. You will need to do these 2. So that's the best way to start to know the tools and to see how a file is. What did I want to say? Oh yeah. So here I have a file of Delft. This is the whole file of the campus. So if I open it with my favorite text editor, which is Sublime Text, the same as Ken, maybe I influence him or vice versa, I don't know. Then you see that I have everything on one line, and that's a pretty long line. And it's the same as what I just said for XML. So this is not really readable, but computers don't really care about that. So if you open it in VS Code, I guess you're using, or CLion or whatever, I think that there's also a function to say pretty print. So I have it in Sublime Text. So if I just open a file like that, I can say pretty JSON, format JSON, and then I obtain something like that. And if you notice, so the original file here is 2.3 megabytes, and then if I decide to print it nicely with spaces and tabs and everything, if I save it, then it goes from 2.3 to 13.2. So with CGIO, when you write a file, it removes all the space and the returns and the tabs and everything so that the file is as small as possible, which is good for computers, good for the web, but bad for you. So if you want to open it and visualize it, then you can just use that. Or there's a switch in CGIO to say save it and save it nicely. I forgot what it is. Maybe I can check. Yeah, so in CGIO, can you still see actually? Yeah. In CGIO, you can say every command, sorry, I'll start with that. So CGIO is here, and then it gives you all the possible commands that you can do. Attribute, remove, attribute, rename, CRS, information, metadata, texture, everything. And if you don't know how to use a command, you can just say CGIO, save, and then help, -- help. And then it says save to a CT-JSON file, blah, 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 indent. Oh yeah, so indent the file, useful when you want to examine the file in a text editor. So if you save something and you want to have the nice part that uses more space, you just put save, indent, -- indent, and then you're going to have it. Are there questions about that? Yeah, just an example how it used. So I have many files here. So I have the file, my file that I just showed you. If you want to know what is in the file, you can just do info, and then it prints information about the file, obviously. But what's interesting is that it extracts some statistics. So you see here, for example, it says, which semantic surfaces do you have? This is useful for the assignment number 2. This is the file that's going to be the start of your assignment number 2. So every building, every surface is either mapped to a ground surface, a wall surface, or a roof surface. This is very important. There's more possible in CT-JSON, CT-GML, but we use these 3. Basically, it says these are the 3 possibilities in the file. And then you have the attributes that are in the file, all of them. Doesn't mean that all objects have that as an attribute, but these are all the attributes that were found in the file. Then I'm going to go to the description of the assignment, which is online since this morning. Yeah, the deadline is what was written at the beginning of the course. We also do group of 3, so all the assignments will be group of 3. 10% per day you're late, same things. 20% of your final mark. And what you need to do for the assignment is basically shown in that figure there. So I showed you last week what is the 3D bar. We have all the buildings of the Netherlands automatically reconstructed by Ravi. And we store a few attributes, but we think that we should have more. So we ask you to calculate these 4 attributes and then to add them to the file of Delft. So you need, for every building that we have in the file, you need to give me its volume. You need to give me the area of the surfaces of the roof. We want that because we want to put solar panels, let's say. The volume we're interested because we want to calculate tax purposes. So the amount of tax you pay is based somewhat on the volume of a building. We want to know how many floors are there. So unfortunately, the government doesn't give us how many floors there are in a building in the Netherlands. So there's like a lot of information, but that very simple attribute, number of floors, is not available. And the other thing is, well, I call it solar potential, but I want to know what is the orientation of the roof. So don't put a solar panel if you're facing north, let's say. Common sense, but I want you to calculate all these things.
So solar potential is just the same as the surface area of the roof, but then only...
No, that's the orientation. Yeah. But it's described more, so I can give you a bit more details. But so the file that you download is the file directly from the server, but it's explained when you start that. Where is it explained? Oh yeah, here. You need to pre-process the file. Everything is explained, but the 3D bar stores more than one LOD, so you will learn a level of detail. So it's possible to have a building. I should have put that slide. I think I'm going to show it to you. Wait, simpler. Yeah, let me show that. Ravi will discuss more details in 2 weeks, I think, but it's good if you know. So as I said, for the 3D bar, what we did, we took the bar, the footprints, we took the AHN 3-point cloud as you use, the same one as you use for the assignment 3 of DTM. We mixed them, and then we did it 10 million times for the 10 million buildings in the Netherlands. But we didn't reconstruct only one level of details, we reconstructed 3. So level of details are, well, they say what they show, so the amount of information that you see in a building. So buildings are really complex, they have chimneys, they have antennas, they have windows, they have many things, but we always abstract this to something simpler. So it's also explained in the handout. So we also work with the LOD, what we call 2.2. So 2.2 is basically the shape of the roof without chimneys and without details. But you can also have the same information with flat roofs or generalized version. So in the file that you download, you have all these LODs together. But for the assignment, we only want you to use the LOD 2.2. So that you need to remove the other ones. So that's why here in the, where is it? Here. So that's why here in the pre-processing of the file, what we ask you to do is basically to filter the LOD 2.2, remove some metadata, clean the file, upgrade it. So you just need to copy that. If it doesn't work, then you have a wrong installation of CGIO, then let me know. But it should work. And then you obtain a file that is called myfile.ct.json, and you start with that. And you need to calculate the 4 attributes that I mentioned. I explained here how to do it, and I will just speak about two of them. That's really. So for the assignment, you have to code yourself the volume. You're not allowed to just find a library that will do it automatically for you. That's cheating. So you need to code it yourself, and we enforce the method that you should be using. That's the easiest method, in my opinion, to do it. I didn't speak to Giorgio, but these are the slides of Giorgio. And for the area of a triangle or even a polygon, you had a formula like that, but I don't know if he explained you where that formula came from. So if you want to calculate, let's say the, I will draw. I learned it once in my life like that, and you will remember it for the rest of your life. So I'm redrawing there because it's simple, but let's say you have a polygon like this, where you have vertices 1, 2, 3, 4, 5. So the idea is that you can either decompose that, so we know how to calculate the area of a triangle, that's simple. But so you could say I will triangulate that building into 1 triangle, 2 triangle, 3 triangle, as we learned in the DTM course, and then I'm going to find the area of every triangle and then sum them. Sounds attractive, but creating a Delaunay, constructing Delaunay triangulation is pretty expensive, and on the web we don't really have the code and so on. So we would like to avoid that. So one way is to decompose a area into something that's called a signed area. So you define a 0, and this 0 can be anywhere. It doesn't really matter. Usually what you do, you could take the bounding box, let's say, make it a bit bigger, and say this is my 0 here. And what you do is, if you have a curve like that one, 1, 2, 3, 4, 5, you create triangles by taking every edge and creating a new triangle like this. So you end up with 1, 2, 3, 4, 5 triangles. So So you have the triangle 0, 1, 2, 0, 2, 3, 0, 3, 4, 0, 4, 5, and 0, 5, 1. All these triangles have an area, and if you remember, to calculate the area is the determinant of a matrix. That's what it says there. And if it's counterclockwise, it's going to be negative, I think, depending on how you do it. But if you calculate the area of, let's say, 0, 1, 2, then it's going to be clockwise, so it's going to be, let's say, negative. 0, 1, 2 is going to be negative here. 0, 2, 3 is going to be negative. 0, 3, 0, 3, 4 is going to be negative. But if you notice here, all these triangles are also located outside my area. But then when I go, then I do the big one, 0, 4, 5. It's going to be positive, but it's going to be all this. But then it's going to be also, so this one was subtracted because it was negative there, subtracted, subtracted. But then here you're going to add the part here for the big triangles. And then if you do it for the end, it's going to be 0, 5, 1, it's going to be positive. Again, this part will be subtracted, this one added. So if you add everything by taking into the sign, so let's say this one is minus 5, this one minus 7, minus 8, this one's going to be 42, this one's going to be 11. You sum everything, you're going to get 22, and you're going to get the area of your polygon. So this nice function that you see there, it's basically doing all that, simplifying everything, and you get it. It's basically subdividing into a polygon into triangle. And look, the 0, I could also have put it in the middle. Let's say you have that, then you could say, and it's going to work. Because sometimes you're going to have counterclockwise, sometimes clockwise, and so on. It's going to work. So what you need to do is you need to take this algorithm and do it in 3D. So you have a building. You need to triangulate its surface, as I discussed last Wednesday. And then you're going to have one triangle in 3D space plus a 0 that you define somewhere. And that gives you a tetrahedra, a sine tetrahedra, positive or negative. And then if you sum everything, positive, negative, you will get the volume of your building. And you need to implement it this way. Yeah?
Last lecture you mentioned that there are some buildings that have incomplete volumes, like would we have to implement things to solve this, or can we assume that the buildings all have closed?
I'll let you decide. So it's not your job to fix the errors, because I don't think you can, but let me know the errors that are there, do they affect this algorithm? If yes, and you cannot, so you need to tell me the algorithms that you use, do they give you the good result you think? So there's like 4% of buildings that are bad, so you need to tell me what you think, maybe with 1 or 2 cases. Can I use that algorithm? Does it fail or not? Of course, if there's one face missing, this algorithm will not work. Like if you have, let's say, this here, and you have a triangle, then it will not work. But if there's a duplicate point or something, does it affect it? I have no idea. I want you to tell me in your report. But I know the answer, obviously, but what did I want to say? Yeah, there's only 4% that are not valid, so most of them will work. And they should give you a value. And oh yeah, to calculate the volume of a tetra, it's on page 129 of the book. It's basically the determinant of a matrix. It's the same as in geo1004, just that you need to divide by 1, 2, 3 factorial instead of 2 factorial. So that's the volume. The number of floor is a bit easier. I want you to take the building, find where is the eave of the building, what is the ridge of the roof by looking at all the coordinates, finding the average. I don't know how exactly I would do it because obviously buildings will not have always the same eaves. It's possible that the front side is higher than the back side. But I want you to find a value that you think makes sense. And then once you find the value of the eave and the ridge, then you find 70% of the difference. You divide by 3 meters because the ceilings in the Netherlands, except in that building, are usually 3 meters. And then you round up to the nearest integer, and you find what is the number of floors. Then the other one for solar potential, you just need to find the area of the surface, the roof surfaces, and their orientation. And orientation, you just need to store a string that tells me, am I southwest, northwest, or if it's a flat roof, then you need to put, I don't know what I put, horizontal. Oh, there's an error here. You just need to put horizontal, and that's it. So the file that you submit looks like something like that. It needs to be exactly the same file as I gave you. You're not allowed to modify it or remove things or do anything. You just need for every building to add volume. You give me the volume as a new, in the dictionary of attributes, a number of floors, an integer. And then for every surface that are roof surface, you need to add something that's called area and orientation. And you give me these values. I don't know if it's a very difficult assignment. I really don't know. Like I'm not trying to, I'm not throwing you here. It's first year we do it. The 3D bar is new. I think it's doable with a group of 3. I know that the volume will take you a bit of time. The height, I think it's very easy. The number of floors, sorry. The surface area is a bit nasty. I will let you discover why. And the last one, the surface orientation, I think is pretty easy. But if you're going crazy during the assignment and you think, because you're supposed to spend 28 hours each, so a group spend basically 30 times 3, 90 hours. If you think it's going way over that, then let me know. We can see, I guess, but I think it's doable. Usually, although some people spend more time than I expected for the last assignment of DTM with the CS, the clot simulation filter. It was maybe C++, so now let me know. We think it's doable. I asked Ravi and Ken, how long would you spend on that? They all told me less than 28 hours. So, no, I'm joking. I think it's doable, yeah. But spend some time. You do need to figure out how CT-JSON works. You need to spend at least 4 or 5 hours to figure it out. And after that, you will struggle maybe a bit with the code. I will give you a few hints right now, 5 minutes, and then after that we can see. Where's my code? I should use C Lion like you. So the example, basically, I gave you 2 buildings from the area that I gave you. It's called 2 buildings. And how I created that file is pretty easy. The only thing I did is I did my file, CT-JSON, subset, give me 2 buildings, and then save them. So if you just type that, then you would randomly select 2 buildings from the file and then create a new file, just to tell you how. So you don't need to start your assignment by using the whole file. You can just take 1 building that you find interesting, subset it, crop it, create a new file, and then just test it. And probably also your algorithm will work on many buildings and then suddenly path is going to crash or something. So don't spend your time with the whole file, divide and conquer. So just find what is the ID where it crashes, create a new file, investigate that one. That's how I work, so I use that things all the time. You can also merge different files. If you want to calculate for all buildings separately for ABC reason, you can create 100 files, create all the files, and then there's a CGIO merge, where you take all different files and you merge them together. So the code is very simple. There's no dependencies, nothing. The only dependency is to read JSON, but that's the same that we use for the last assignment. We give you the code. Cannot start process. How does it work? Not even sure if I know how CLion works anymore. Hold on. Yeah, okay. So I can go over the code. You can just tell me if you don't understand some lines maybe now. Does it need to be bigger maybe? Is it useful if I go over the code, or I'm doing something redundant that you all know? Think it's useful? Okay. So here we include some things that we need. So IOStream, fstream is to read the file. We're going to deal with string. I'm not even sure if I need it. But I think so, I guess so. And then json.hpp is the file that I use to read and write JSON. Okay. And then I rename here nlowman JSON. So we're using the most popular JSON library in C++. Everyone uses it. It's everywhere. The guy is called Neil Lowman, I think, or N is German. So instead of all the time typing lowman JSON, then we just type JSON. So we rename that. I have forward declaration of 3 functions that I say to my compiler, hey, you're going to hit these functions later. So it's not like Python. The compiler needs to know if main is at the top. If main was at the last one, then they would read the file before. But since they read the file from top to bottom, when they read the main, then they need to know that these functions will be there. So in the main here, what I say is that I read the file that I just showed you. So dot means go up one folder, go up one folder, go to the folder data, read the file to buildings. I read it to input, and then I create an empty JSON object. And then I put the input into the JSON object, and then I close the file. So now this step here, since JSON is a combination of STD maps and STD arrays or vectors, STD vector usually, then all the file that I had with all the buildings, with all the attributes, everything, are automatically parsed to a set of arrays and or dictionary or a match of them. It's a bit more tricky than that, you will see in a second, but basically that's what's happening there. And then I have a few functions here that give you, that show you what you can do with the file. I commented them out because they output a lot of things. Let's skip them for the time being, let's say. And then if I just run this. So, oh, I didn't save it, I think. Yeah, okay. So now if I run the file there, I read the file, then I say I would like to count how many buildings are in my file. Yeah, I will just open the file here. So as I said, if you want to see the file in the details, the best way is to use Firefox. So if you just open that file here, then you can see that you have a lot of vertices. You have something like 184 vertices, and you have 4 city objects. 2 are buildings and 2 are building parts. So what I do in the code right now is that I say a number of buildings, and then what I say is that I say for every object in my city object, if the type is building, increment the number of building. Then it will go over 4 objects. 2 of them are building parts, 2 of them are buildings, and it's going to go to 2, and then at the end it prints there are 2 buildings in the file. When I'm here, it just prints that. Pretty simple, but that gives you an idea. And then number of vertices, then 185. That's also what I had here. I had 184, but it's 0 based, so then it's 185. And here I show you how to add an attribute. So if I would like to add the volume attribute, then I basically go over all my city objects. If it's type building, then in the property attribute, I add volume, and rand means give me a random number. So I add it there, and then at the end, if I just say JSON.dump, and you see here they use the same idea. Indent to, it means that don't put spacers and make it readable for me because I'm a human, but if you remove that, then it would be good for computers. And then you close it, and then I save it to myfile.json. So then if you go in the folder where you have your executable, which is client created cmake build debug, and then this file here, if I drag it to here, these were all the attributes that I had already. Yeah, so the attributes, unknowingly, they're a mix of Dutch and English. So DAC type, which means roof type, slanted. So DAC is roof. You can also ask anyone who's Dutch, or you can ask me if you don't know. And these are the height of the DAC, height of the roof, at different values. So they give you an idea of all the point clouds that we use. We calculate some statistics. And myfelt, so myfelt is the ground, basically. It means the height or the elevation of the myfelt, so it means that it's at minus 27 centimeter. So there's a lot of data, and a lot of attributes that come from also the bar, blah, 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 blah. And if you see here, I have volume, and my volume is 16,807. That was a random value that was put there. So that works. The other function that I will just show you in a sec, or you can maybe read, I will just discuss them now, and then maybe you can have a look at them, and then Monday I can answer a question, I guess. Yeah, let's look at that one. One function returns a number of roof surface in the model. So basically, when you enter here, get the number of roof surface, I give the whole model. I wouldn't need to do that, but just for convenience, I say I give you the whole model. You know what the ampersand means? You give by, not by value, but by reference, so you don't copy the whole object, so it doesn't really matter. Basically here what I say, I do the same thing as above. Okay, if you notice here, I wrote for auto ampersand CO. For every city object in city object, do ta ta ta. Here I wrote it a bit differently. I wrote for every city object dot items. That's because above I only got access to the value, not to the key. Here I was also interested in the key. So if you say give me the items, then you can get and the key and the value that you get for all of them. So here if I say the value, so I iterate over all my object, I iterate over all the geometry, And then if a geometry is a solid, all our buildings are solids, then I start to search in the semantic values, and then if the surface is a roof surface, then I increment it. But you will need that function, or you will need to modify that function, because I ask you to calculate, to add attributes to all the roof function, all the roof surface. So then you need to find how the roof surface are there. It's you will need to read in the specification how it's done. It's a bit, so there's two arrays that are separately. So you have the geometry and the semantic, and they're aligned. So that function basically visits them at the same time. You will understand if you read it, but you need to do that. That's probably the most complicated part for the for this. I also wrote that function because of this. That's the last thing I will see for that function. So I say if my geometry, the semantic, the surface, and then let's go to the So here I have a geometry. It's a multi-surface, but it could be a solid. And I have semantics and I have surfaces. And if you see, I have an array here of semantic surfaces. One is a wall surface, the other one is a roof surface, the other one is a patio door. So here this code does that. So it says, if the geometry, semantic, surfaces, and then here I need to give an integer because the surfaces is an array here, so I need to say give me the first one, the second one, the third one, and so on. But I said that the JSON library will automatically take all the arrays and dictionary and then pipe them to something. It's true, but sometimes they don't really know what they have. So since you have a text file, and then you read a text file and you convert it automatically to a data structure, if you have a number, sometimes you don't know, am I an integer or am I a float number? So they cannot really know directly. So you need to tell the compiler that what you get there, so this function s get, and then with the, I don't know how it's called, arrows, integer means that I know I have an integer, cast it to an integer. You know what is casting? I guess you know what is casting. So this is one way to cast something to an integer. And here I also say cast something else to a string. It's possible that you read something as a number, but you want to have it as a string, so you can say cast it as a string. So this function does that, and I'll let you read the other function. One function gives you all the vertices. You need to do that because the vertices are stored in integers, and you need to convert them to float. It's explained in the specs, and you can just use that code. It's pretty easy. And the other function, visit all the roof surfaces, does more or less the same thing as this one, but by using other types of loops. So I think that this is enough for you to start. And last thing I will say, you don't need to write one whole program that does the whole thing in one shot. You can write 4 different programs that do every attribute, and at the end you need to figure out how you how you merge all the attributes together in one file. So in teams of 3, we don't want to have someone that does all the coding, someone that is the administrator that tells other what to do, and someone that writes the report. So there's 4 functions to create. So one of you should at least, someone can write 2, I guess, but everyone should have at least one of these 4 to work on them. That's pretty important for us. We also ask you to be honest and then say who did what. But you can have 4 different codes and then figure out, well, you need to have a goal how you're going to merge them at the end, but you can almost leave it for the end. And yeah, that's it. And you need to submit your code. But it's not as if I'm going to run all the code. I will check the code to make sure that you didn't use another library or something. So you need to give me instruction like you did for DTM, how to compile your code. Usually it should just be CMake. You shouldn't add anything else, but you're allowed to add new units or something, but you're not allowed to find a get me the volume magically. That doesn't work. All right. That's it.
If you're facing challenges, are we allowed to replace the deadline extension?
If you face a challenge, what?
If we face any challenges with this assignment, we're allowed to request deadline extension.
No. No, that sounds a bit. Is there a problem already? We don't do deadline. I don't do deadline extension personally, but Ken is in charge of that course. I don't know, but usually we don't do because in the past I've done it because for me it doesn't change anything. But then I know that some people worked whole night and then they wake up to be told, oh, it's all right, you can submit it tomorrow, and then they're really angry. And I also understand why. Like maybe they would have preferred to sleep. So we extend deadlines if it's done like a week before and you know there's something, but do you have other deadlines at the same time? This we can agree on something, I guess, but right now we don't extend deadlines, we give the same time to everyone, and that's it. All right.